Hello friends, today we are going to talk about physical quantities and units in this video. Let us start with physics. What is physics? Physics is actually scientific study of natural phenomena. Okay, but then it's not just you think of something or you observe something and then that becomes physics. It's not that. It's natural phenomena, and then you apply certain laws or certain mathematical formulae and all, right? And then those become those phenomena, they become physics, correct? Now in physics we need to measure things, isn't it? So when I say mass of this marker or maybe length of this marker, we need to measure the length, we need to measure the mass, correct? So for that we need to define something called physical quantity. A physical quantity is a quantity which can be measured, correct? Now based on how we do it, right, we divide these physical quantities into two types. Now one type is fundamental physical quantity and other is derived physical quantity. Now what is fundamental quantity? Something like mass. I say mass of this marker is 40 gram, or length of this marker. Length of this marker may be something like 15 centimeter. Now for length and mass, for measuring length and mass or expressing length of this marker or mass of this marker, did I need any other physical quantity? No, right? So this type of quantities, they are called fundamental physical quantities. Okay, but then if I have to measure the speed of a car, so for measuring speed I need to measure the distance it covers in given time. Okay, so the speed can be something like 100 kilometers in 1 hour, correct? So you need distance and time for getting speed of the car, isn't it? So speed becomes my derived quantity, fundamental quantity and derived quantity. So length, mass, time, these are fundamental quantities. Speed, it can be force, correct? And pressure, area, these are derived quantities. Let us list down the fundamental quantities. Now length is there, mass, then time is a fundamental quantity, then it is temperature, current flowing through a conductor, amount of substance, and luminous intensity. Luminous intensity of light. Okay, so length, mass, time, temperature, current, amount of substance, and luminous intensity. Now here mass is measured in kilograms or grams even. I would say length is measured in meter, time is measured in seconds, temperature is measured in Kelvin. When we say Kelvin, it is absolute temperature. Current is measured in amperes, and amount of substance is measured in mole, and luminous intensity is measured in candela. Okay, now here you must have seen I have written this kilogram, meter, seconds, Kelvin, and ampere, and mole, and candela, right? These are units. Now what are these units? When I say length of a rod is, let us say, 1.5 meter, this 1.5 is the magnitude and this meter is the unit, correct? So 1.5 is the size and meter is the unit. So that means the length of that rod of which I am measuring, that rod under consideration, okay, it is 1.5 times some standard length. Okay, that standard length is 1 meter. Okay, and then we compare other lengths with that standard, correct? So 30 meter, okay, 30 meter means 30 times the length of that standard rod, correct? And then same is the case with kilogram. Okay, there is 1 kilogram is the basic standard that we have, okay, and maybe 3 kilograms is 3 times the mass of that. Same thing with seconds and Kelvin and so on. Okay, now absolute temperature I said. Now what is absolute temperature? It is I'll just tell you the conversion. Temperature in Kelvin is equal to temperature in degrees Celsius plus 273.15, correct? So that many, so plus 273, so Celsius temperature plus 273.15, that is equal to my Kelvin temperature. Now what is this Kelvin scale? Kelvin scale, absolute zero of Kelvin scale is that temperature at which the intermolecular movement, it ceases, okay, the molecules come to complete rest, okay, and that temperature is called absolute zero, and then that happens at minus 273.15 degrees Celsius, right? So these are the fundamental physical quantities. Then there would be derived quantities. Derived quantities are like, speed or velocity, and acceleration. Acceleration is what? Change in velocity per unit time, or rate of change of velocity, correct? So over there I have to divide velocity, change in velocity, by time. So, and even velocity, for velocity I need, change in displacement per unit time, isn't it? So acceleration is a derived quantity. And if I have to talk about force, force is what? Mass times the acceleration. So force is also a derived quantity. Pressure, pressure is force divided by area, force acting per unit area, correct? So you will be dividing force by area and then you get pressure. Okay, what about area? Area is again area of a rectangle. Let us say it is length multiplied by breadth, correct? So that is how you get area. So again, then coming to units, units of fundamental quantities are called fundamental units or base units, and units of derived quantities, they are called derived units. So how do you get derived units? You just express that derived physical quantity in terms of fundamental quantities, then add the units of fundamental quantities over there at respective places, and then you get the unit of derived quantity. These units help us estimating different quantities. Now what is estimation? Estimation is basically a skill, okay. I'll give you an example. Again, this marker, length of this marker, okay, length of this marker is about 15 centimeter, correct? So suppose you are expected to estimate length of a pen, okay, and you are given something like this: 1.5 kilometer, 0.15 meter, 0.75 meter, and 0.025 meter. Now how would you choose the right thing? Okay, 1.5 kilometer, a pen having length 1.5 kilometer, it is, that's not the option. 0.15 meter is how much? 15 centimeters. So this seems to be correct. 0.75 meter, okay, 0.75 meter, 750 millimeter or 75 centimeter, this is also not something possible. 0.025 meter, so what is that? So it is 2.5 centimeter. 2.5 centimeter would be something like this, okay. Even this would not be appropriate, so this would be the right answer. So now here one thing is there, 1.5 kilometer. How big is 1.5 kilometer? So isn't that 1.5 multiplied by 1000 meter? So that is 1500 meter. 0.15 meter, okay, so it is uh, it is 15 centimeter, 0.75 meter. Okay, so I convert that into centimeters, so I multiply by 100, so it would be 75 centimeter, and again this 0.025 meter, so that would be 2.5 centimeter. Correct. Now here you see kilometer, centimeter, 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 right? These are different, these are multiples of basic unit. So how do we do that? Now one more example. Suppose I am going from Mumbai to Pune, okay, and the distance is 150 kilometers. Okay, is it convenient expressing that distance or any distance in kilometers, distance between two cities? Okay, it is convenient to express in kilometers. Okay, but then 150 kilometers, if I multiply that by 1000, so that would be 150,000 meters. Correct. It's not convenient to express the distance in between two cities in meters, isn't it? What about millimeters? So again you multiply by 1000, so that would not be convenient. So kilometers is convenient over there. Now length of this marker, okay, if I express that in kilometers, no, that would not be convenient. Centimeters is more convenient. Okay, now thickness of a paper, okay, thickness of sheet of a paper. Now over there, is it convenient measuring in centimeters or meters or kilometers? We need something smaller than that. Okay, thickness of paper could be measured in maybe micrometers or maybe fractions of millimeter. Correct. So we need to define these subunits. Like when I have something like kilo, that means I multiply by 1000. When I have mega, I multiply by a million. When I have giga, I multiply by a billion. Multiply by a billion, that is 10 raised to power 9. And when I have tera, I multiply by 10 raised to power 12 here. Correct. So these are the larger units. Now even this kilo, I will write in terms of powers of 10. Rather than writing 1000, I'll write 10 raised to power 3. Okay, so 1 kilometer is 1000 meters. Correct. So like that. Now what about smaller units? So when I divide a meter by 10, it is called deci. So deci is divided by 10, so into 10 raised to power minus 1. Centi divided by 100, 10 raised to power minus 2, multiply by 10 raised to power minus 2. Then milli divided by 1000, 10 raised to power minus 3, multiply by 10 raised to power minus 3 here. And then micro, that is multiplied by 10 raised to power minus 6. Nano, 10 raised to power minus 9. Pico, 10 raised to power minus 12. So these are the prefixes to be added to the basic units. So centimeter, so centimeter is 100th part of a meter. Decimeter is 10th part of a meter. Millimeter is 1000th part of a meter, and so on. So we use micro, nano and pico like that. So these are basic things that we follow while expressing the size of physical quantities. Okay, and then we go to this units of fundamental and derived quantities. I told you that for getting units of derived quantities, you just have to put the formula over there and then substitute the units of fundamental quantities or substitute the base units. I'll give you an example. So let us say force We know that force is mass multiplied by acceleration, right? So for getting unit of force, I'll substitute units of mass and acceleration. Okay, so now mass is kilogram, so 1 unit of force is equal to 1 unit of mass multiplied by 1 unit of acceleration, right? So 1 unit of mass is kilogram, 1 kg, multiplied by unit of acceleration, it is meter per second square, 1 meter per second square, right? So 1 unit of force, so 1 Newton is the unit of force, correct? It is 1 kg meter per second square. So similarly, if I have pressure is equal to force divided by area, so that would be 1 kg meter per second square divided by meter square, correct? Area is meter square, so that would be 1 kg meter raised to power minus 1 second raised to power minus 2. Now if we think of work done or energy, okay, energy, we know that, you know, this object, okay, it is at this level and I just drop it, it is going to fall down, correct? So initially when it was here, its speed was 0, and when it reached my palm, it had got certain speed, that speed was v, okay? So initial its kinetic energy was 0, but then it had potential energy with respect to ground, and in this case ground is my palm, right? So that potential energy got converted into kinetic energy. Potential energy was equal to mgh, where h is the height above the ground, and then kinetic energy, right, it is half mv square. Now what about unit of mass? Kg. Unit of g is meter per second square, and unit of height is again meter. On the right hand side, let me see what it is. Half I am ignoring, but mv square, so mass is kg and v square, so that is meter per second, correct? So now kg meter square per second square, and on the left hand side it is kg meter square per second square. So that means this equation, the equation is homogeneous, correct? If you take any example of kinematical equations for constant acceleration, if I say s is equal to ut plus half at square. So if I check units on both sides, now on my left hand side it is displacement, so unit is meter, correct? On my right hand side it is u into t, so u is my speed, so it is meter per second multiplied by time, time is again second, plus half into a, acceleration is meter per second square and t square, so that is second square, correct? So if you check this s gets cancelled here, this a square gets cancelled here, and so left hand side is in meter and even right hand side is also in meter, correct? So that shows that, you know, these equations are homogeneous. The units on the left hand side and units on the right hand side are equal. So that was about physical quantities and units. In the next video we are going to talk about errors and uncertainties. Thank you so much.